Okay, so the last part of chapter 8 is again doing some modelling questions, but this time we're going to be doing a modelling question where the parametric equations include some things to do with trig. This question is a bit of a strange one because it's going through different things to do with, creates a really weird graph there. You can see the graph is doing this sort of strange figure of 8 shape. Let's start reading through the question. It says the motion of a figure skater relative to a fixed origin O at time t minutes is modelled using the parametric equations x equals 8 cos 20t and y equals 12 sine 10t minus pi over 3, with t being greater than 0, where x and y are measured in meters. Now this looks complicated, but it's still going to follow the same things that we've been doing in all of the questions previously. So it first of all asks, find the coordinates of the figure skater at the beginning of his motion. So that's telling us something in disguise there. The beginning of his motion is just telling us that t is equal to 0. So it's just going to be a substitution for these beginning bits. And I want to try and do this substitution. We can probably do most of this without a calculator. So if t is equal to 0, what is the cos of 0? 1. So 8 times 1 is just 8. And then we're going to say for y, we're actually trying to work out 12 sine of 0 minus pi over 3. So it's the sine of minus pi over 3. Anyone think they could work out what the sine of minus pi over 3 is in their head? Very good. So this is 12 multiplied by negative root 3 over 2. The way that Shahan thought that is he knows that sine of pi over 3 is sine of 60. And I'm guessing I remember sine 30 as a half, so I knew it was the other one, which is root 3 over 2. And because it was a negative, you can either think of the graph or you can think of the cast diagram. We knew that this had to be negative 2. So you get minus 6 root 3. So the coordinates where the figure skater is at the beginning is x minus 6 root 3. Not x, sorry, 8 minus 6 root 3. So looks like you can see this as a negative 5 over here. It looks like it's probably starting at this point. I'm just going to check what 6 root 3 actually is to see if we can work out where that is. Pardon? Minus 10.4. Oh, actually, so probably starting somewhere. Oh, no, it couldn't be over there. I've put that in negative 8. So I think it's probably this is where the starting point is, because we can see that this is roughly 8 and this is the minus 10.4. So this is where, at the beginning of the journey, the figure skater is, the ice skater. It wants us to find the coordinates of the point where the figure skater intersects his own path. Okay, so intersecting the own path, we can see from the diagram, is on this part of the axis. What can we tell at this point on the axis? Y equals 0. So in disguise, it's asking us to say, when is y equal to 0? So we're going to take this that we have, and we're going to say that 0 equals 12 sine of 10t minus pi over 3. So we're going to find out what t is, and then we're going to use that to find out what x is. So I can divide both sides by 0, so I just get 0 equals sine of 10t minus pi over 3. So what values of sine give us a 0? What will the argument, what will the angle be of sine that gives us 0? Think of the 0 degrees or 0 radians. So actually the solution to this, you could either do the inverse sine of 0. You're just going to get 0 equals 10t minus pi over 3. Obviously it's not just 0. What other values could it be equal to? It could be not pi over 2 for sine. Pi. It would be 0, pi, 2 pi, 3 pi. But in this case, we only want to find out what t is. We don't need to find out all of the values of t. We just need to find out what t is. So I'm going to solve this equation by doing pi over 3 is 10t. So t is pi over 30. I've just done pi over 3 divided by 10. So the next thing I'm going to do, actually, just want to talk about that a little bit more. Pi over 30 is a very small number. Pi over 30 is 0.1047. But what is time being measured in this question? Pardon? It's in minutes. So if I multiply that by 60, I get 6.3 seconds. So from here to here, it's taken 6 seconds for the ice skater to get to this particular location. Okay, just to think about what's actually happening in here and what all of the different things mean. So at this bit here, it's taken 6 seconds. Then they're going to do this other bit of the pathway, and then they're going to keep looping around in this particular thing. Okay. So we've got that bit is 6.3 seconds. We're going to leave it as just t equals pi over 30. We're trying to find, though, the coordinates of this point. So what do you think I should now do? Yeah, I'm going to put that into x. Now, we know that x is equal to 8 cos 20t. So it's going to be 8 cos 20 multiplied by pi over 30. So that is 8 cos of 2 pi over 3. And I'm going to be lazy. Cos of 2 pi over 3 is minus a half. So that's 8 multiplied by minus a half, which is minus 4. So we have that the coordinate of where it intersects itself is at minus 4, 0. Does that match up? Does that corroborate with our diagram? Yeah, it is. It does look like it's at minus 4, 0, doesn't it? And it does look like it's at minus 4, 0. Quick question, though, or not really a question, something for us just to think about. When we were solving this equation down here, I said that it could have been equal to 0, but I said it also could have been equal to pi, or 2 pi, or 3 pi. So when I solved this, I would have got lots of different values for t. What does that mean if there's lots of different values of t where it could be at this point? Good. Okay, good. So this isn't just one journey that this ice skater is doing. They're actually starting here. They're going around like this, and then they're coming back, and then they're going around like this, and they're coming back. Okay, so the reason why there could potentially be a lot of different values of t here is because there's a value of t initially, then there'll be another value, another value, another value. So it's just going to keep happening and happening because of the way that trigonometry works, that it just goes round and round and round. Okay, then we're going to find the coordinates of the points where the path of the figure skater crosses the y-axis. So crossing the y-axis is obviously going to be here, here, and the 2 at the top as well, which is when x is equal to 0. So we're now going to say that x is equal to 0, which means that 8 cos 20t is equal to 0. Which means, if we divide by 8, that 0 is equal to cos of 20t. And we need to find all the places where cos is equal to 0. So you can either use your calculator to do the inverse cos of 0, which will give you your first one. What's the first solution? 90 degrees, or in radians, because this question is all in radians, pi over 2. So we get pi over 2. Now, why do you think I'm going to need to find more values this time than I did on the previous one? Yeah, because there's not going to just be one single time or one single position. There's going to be 1 time, 2 times, 3 times, 4 times. So I need to make sure that I'm going to get a lot of different solutions here that's going to help me to generate these different answers. So what are the ways that I normally solve a cos graph? I do 360 minus or 2 pi minus. So this is my initial one the calculator gave me. If I do 2 pi minus a half pi, 2 minus a half is 3 over 2 pi. And I'm going to just write it underneath it like this, okay? And do you remember what you're allowed to do to trig equations to come up with the next solutions? You can add 2 pi onto them. So I'm going to add 2 pi onto this one. So think 2 plus a half, 5 pi over 2. And if I add 2 pi onto this one, so I'm doing 1 1/2 plus 2, 7 pi over 2. And I'm going to stop at that point there because I think that's going to correspond to the 4 solutions that I'm looking for the time. What do you think would happen if I did find another one?
It would be on the second lap.
Yeah, it would be on the second lap. So these ones are going to be on this first lap all the way around this ice skating figure of 8. If I did come up with another 2 by adding 2 pi and adding 2 pi, they would actually correspond to the first 2 that we already had. If we were to actually work out those coordinates, they would come back to the same point. Did you have a question? Okay, so we haven't quite finished this yet because this is what 20t is equal to. So we now want to say what t is equal to. So I'm going to take all 4 of these answers and I'm going to divide them by 20, which is going to give me pi over 2 divided by 20 is going to be pi over 40. I've simply just multiplied the denominator by 20 here to make it 20 times smaller. And this would be 5 pi over 40. This one, when I divide it by 20, would be 3 pi over 40. And that one would be 7 pi over 40. So then I'm going to take these values, and what am I going to do with them? I'm going to plug it into the y one, and the y one is 12 sine of 10t minus pi over 3. And we're going to have to work that out for all of these coordinates that we've got here. So I'm going to start off with t being equal to pi over 40. So that will be 12 sine of 10 times pi over 40, which is just pi over 4 if you multiply that by 10. So that's pi over 4 minus pi over 3. And I'm just going to be a bit lazy and just put that in a calculator because that's quite a lot of work. So that's the 12 sine of this minus this. And you do get it in an exact form, but I don't think we need to give this an exact form here. I'm just going to say this gives me, when I did it, minus 3.11, and that's to 3 significant figures. Did everyone else get that as well? So we're going to do the same for the other values. We're going to do it with 5 pi over 40. So that's, instead of it being pi over 4, it will be a 5 pi over 4 because we've multiplied it by 10. So you just need to go through your calculations and just change them. And this time I get 3.11 to 3 significant figures. I'm going to keep going. I'm not going to write out everything that I do here. So I've done these two. I'm going to do this one now. Don't need to write absolutely everything in here. And I get 11.6 to 3 significant figures. I'm literally just going through the bit in my calculator and I'm just changing it from pi over 4, 5 pi over 4. This one then would have had a 3 pi over 4 because of this. And my last one, when I have 7 pi over 40, is going to be that y is equal to, let's change it so I've got a 7 pi in there instead. Good, minus 11.6 to 3 significant figures. So we've got these 4 coordinates of where it crosses. We have 0 and 3.11, 0 minus 3.11, 0, 11.6, and 0 minus 11.6, which is great because we wanted the 4 different solutions that we had. If you've written that all down and just want to listen to what I'm going to say next, I just want to double check. If I added 2 pi to this, I would have had 9 pi over 4. I would have then got 9 pi over 40 as an extra one. When I would do a substitution in, this would have been a 9 pi over 4. If I change it to a 9 pi over 4, I actually come up with a minus 3.11. So they do start then repeating themselves, okay? I wanted to show you that if you did find more solutions than the 4 that you needed here, they would then start repeating themselves as the ice skater keeps going around this link that we've got here. So the maths looks hard here, but I think the reason it looks hard is because there's loads of pies and there's lots of stuff that you've been doing in recent lessons that makes it look hard. But really, this is just coordinate geometry. It's just saying, where does it cross the x-axis? Make y equal 0. It's just that same process again, okay? There may not be enough space to get this last bit written in on your page. I think next time I'm going to need to make sure to give you a bit more space for this, because this question took up a lot more space than I remembered. So finally, we've done A, B, and C. D says, determine how long it takes the figure skater to complete one complete figure of 8 motion. So there's a few different ways that you could do this. So I guess we could think about this bit that we've got over here. We could think about all the times when it goes back to the beginning. I'm probably going to show you 2 ways of doing this. I'm going to start off doing one way that I think you'll find easier, and then I'm going to show you another way that is to try and deepen some of your understanding, especially if you're aiming for some of the top grades. So we know to begin with, when time is equal to 0, it had this particular coordinate that we've got here, okay? It looks like it's going to go back to this coordinate of 8 when it's up here, and then it looks like it's going to come back to the coordinate of 8 later on as well. So I'm going to just investigate the idea of the x coordinate being equal to 8 and see if I can find out how long it takes for that to happen. And then I'm going to do a different method for this afterwards. So for part D, at the start, we know that x is equal to 8. And when we have that equation, we get 8 equals 8 cos 20t. Okay. 8 equals 8 cos 20t. And I'm just going to go about solving this equation to see if I can find out when it has an x coordinate 8, and hopefully I can find out when it comes back. So I'll divide both sides by 8, and I get that 1 is equal to cos 20t. So what do we think the values of 20t are going to be when I do the inverse cos of 1? What's the inverse cos of 1? It's 0. Remember, you can always do this on your calculator, so you get 0. And when would the next time be? Remember, you can use the rules of doing 360 minus or 2 pi minus. It would be 2 pi. And then when would the next time be, do you think? 4 pi. Okay, because you could add 2 pi to this or add 2 pi to this. And you could also add 2 pi again. So we've got these 4 times here when the x coordinate is 8. I'm going to go back to the diagram, and we're going to see if we can work out what the 4 times correspond to. So this was when t was something to do with 0. When do you think the 2 pi solution is going to correspond to? Yeah, it's probably, I'm guessing it's going to correspond to something to do with this, but we'll still have to actually calculate what the value of t is. I think that will be 2 pi. I think that would be 4 pi. I think that would be 6 pi, etc. Okay? So I'm going to concentrate now on just this 4 pi one. I think this is the one when it's going to return to the start. I think this one is going to be when it's at the top point, and I can investigate that if I need to. So I'm going to say for this one that I've got here that t would be equal to 4 pi over 20, which is just pi over 5. How can I confirm whether it has gone back to the starting point when t is pi over 5? What do you think I could find out that might help me decide that? The y coordinate, and y needs to be minus 6 root 3. So y is equal to, what is y equal to? Is it 12 sine 10t minus pi over 3? So I'm going to substitute pi over 5 in here. So that's 12 sine of 10 times pi over 5 is 2 pi minus pi over 3. So let's see what we get. 12 sine of this minus this. And we do get minus 6 root 3. So it has returned. So I think that if you do need more space, the back page is blank as well if you've run out of space, okay? So it has returned at this point. What do you think the answer would have been if I was using 2 pi instead of 4 pi? What do you think this coordinate would have been? positive 6 root 3. Let's look back at the graph for a second. If this is negative 6 root 3, it seems symmetrical that this would be positive 6 root 3. Okay, so it has returned at that time, but we need to try and change this from saying, oh, it's taken pi over 5 minutes. We probably want to make that into something that an ice skater would be able to understand. So the answer is that t is equal to pi over 5, and pi over 5 is 0.62 something minutes. So I'm going to multiply that by 60 so that I can just understand it a bit better. And I get that that is 38 seconds. So it takes 38 seconds to do this overall loop.
So do we need to give the answer exactly?
I don't know. I think if you said 0.62 minutes, that would be fine. But time is one of those things we don't ever really say to anyone like, oh, I'll be there in like 0.8 hours. We would always say it in like the units that's more appropriate for people to understand. So really this example is kind of interesting, and it's here to show you that when you do parametric equations where there's trigonometry, things will keep looping around and around and around. Whereas when we did the example with the dolphin jumping out of the water, that was something where we restricted the amount of time, and the same thing with the aeroplane. This one, in theory, could keep going forever and ever and ever. Now, I did say there was going to be a second way that we could think about this, and this one is a little bit more complicated, but it's to do with how often things repeat themselves. So if this next bit confuses you, that's fine. Just concentrate on what we did for this last part. But really what happens here is we want to think about the cycles of how long the cycles actually take. Now, normally when we have, this is an alternative method for this last part, if we have a graph that is like sine t or cos t, how long does it take for these things to do a cycle? What is the length of a period for these? Pardon? 360 degrees, or it would be 2 pi radians. That's how long one of these things would take, okay? So if I had something like sine of 10t, what do you think that would do to the graph? What transformation would that do to a graph? It would squish it by a factor of 10. So how long would this one take to do a whole cycle? Pardon? Yeah, so in radians, though, what would you do to the amount of time it would take? It would be pi over 5, because you would take 2 pi and you would divide it by 10. So the amount of time that one would take, it would repeat. It repeats every pi over 5 minutes. Okay, and our graph was almost that. Our graph was 10 of sine t minus pi over 3. Will minusing pi over 3 from the time section, will that actually change how long it will take? What does it do? What does this minusing pi over 3 do to the graph? What kind of transformation is that? It's a translation, so it's not going to change how long the cycle actually takes. This is the thing that will reduce the cycle's time by multiplying it by 1 over 10. Okay, so the sine graph, the y part is cycling every pi over 5 minutes. The cos part is cos of 20t, ignoring the bits at the beginning because we don't need that. So how often would this one repeat itself?
Do you not need the 12?
The 12 is not going to change how often it repeats itself. That's just going to change how stretched out it is up and down. It's not going to change how often the graph repeats itself. It would be pi over 10 because it's 2 pi over 20, which is pi over 10 minutes. So this is now the bit that's a conceptual thing that is here just to try and stretch you if you're wanting to aim for these top grades and to think how these graphs are working. If the y coordinate is repeating every pi over 5 minutes, and the x coordinate is repeating every pi over 10 minutes, when will they both have repeated and be at the same time? So this one is going every pi over 10, this one's going over pi over 5. You can think about this as 0.1 pi, and this one as 0.2 pi. At what point will they both have repeated at the same time? Pardon? At 0.2, yeah, because this one is going to be repeating at 0.1 pi, It will then be at 0.2 pi, it will have gone back to its same place, at 0.3 pi, at 0.4 pi. Whereas this one will be going 0.2 pi, 0.4 pi, 0.6 pi. So the place where they both will have repeated and be at the same point is at 0.2 pi, which is pi over 5, which is 38 seconds. So you can also think about this in terms of how often things are repeating. It's the what, sorry? It's the lowest common multiple of these two things that we've got here. And that's the way that the textbook answers this question. And I don't like this one quite as much as the way that we did it in part D. But it's nice to kind of see it as thinking that you can think about all of the stuff we've done so far to do with graph transformations and trying to understand what these things are actually referring to. So let's just really quickly go back to the graph and see if we can interpret this one more time. So the x part was the one that was going to repeat every pi over 10, or 0.1 pi. And that is because, is that right? Yeah, it's going to go over here and over here. It repeats in more places. No, the x part only repeats here and here, whereas the y part will only repeat at the same time. It's kind of actually hard to see it on the graph. I think that last bit I was saying doesn't make much sense. But hopefully this bit that we did kind of makes a bit of sense for this part of the question. So the trigonometry ones are much more demanding, but the reason I think they are more demanding is because solving trig equations in radians, and they just don't feel as familiar to you as things to do with quadratics and polynomials. And the way we get better at those is doing practice. So we're going to do a few questions to have a go at some of this, and then we'll do some new stuff for the next part of the lesson, okay?